Hey guys, this video is about adding the terms of arithmetic and geometric sequences under the topic of sequences and series. In this video, we will explore summing arithmetic and geometric sequences and how sigma notation is related to this process. Adding the terms of a sequence is known as finding the sum of a series. This is denoted by the term Sn. To sum a sequence, we must first identify a few of its terms. This is shown here on the example, where Sn equals to t1 plus t2 plus t3 all the way to a final term Tn. When summing a sequence, the term n represents the number of terms you are adding. For example, below we have S2 equals to t1 plus t2. So the value of n is 2 as we have two terms. So, what is sigma notation? In maths, sigma notation is just an alternative way of displaying a sequence. This example below shows the sequence defined by the formula Tn, written in sigma notation. To read this example correctly, we must know that the number on top of the Greek letter sigma, in this case is 9, is the term of that the sequence is finishing at, while the term at the bottom of the sequence is the term that it starts at. So in this sequence, we see that n equals 3, so we start at the third term. We also see the sequence finishes at the 9th term, so we finish at T9. Now we move on to summing an arithmetic progression. To revise, we know that an AP is given by terms which are separated by a common difference. As such, summing an arithmetic series involves two different formulae. Both formulae are used, but they are used in different scenarios and contexts. For example, the formula on the left, Sn equals to n on 2 times a plus l, is used when we know the last term of the sequence. This is because the variable l represents the last term, thus making it easier to calculate. Example 1 asks us to find the 10th term of an AP. If the sum of the first 10 terms is 275 and the first term of the sequence is 5. A good first step to take is to write out all known knowledge from the question. Here we can write out the sum of the first 10 terms is equal to 275 and a, which is the first term of the series, is equal to 5. Because the question is asking us for the last term of the sequence, we can use the formula n on 2 multiplied by the sum of the first and last term. Going through the simple algebraic working, we can see that the last term of the sequence turns out to be 50. Now we move on to summing a geometric progression. To revise, we know that GP is given by terms which are separated by a common ratio. As such, summing a geometric series involves two different formulae similar to that of an AP. These are shown here, with their only notable difference being r minus 1 in the first equation for the numerator and denominator, and 1 minus r for the second equation in the numerator and denominator. This is done to account for the common ratio when it is either greater than 1 or less than 1. As such, when dealing with problems, you must use the appropriate formula depending on the value of the common ratio. Now we move on to an example question relating to summing a geometric progression. Example 2 asks us to find the sum of the first 9 terms of a GP, 2, 4, 8, 16 all the way on to infinity. A good first step to take is to write out all known knowledge from the question. Here we can write that both the common ratio and first term of this sequence are equal to 2. Because the common ratio is more than 1, we have to use the corresponding formula. Thus, by substituting in points and solving algebraically for the sum of the first 9 terms, we can see that S9 is equal to 1022. Now, in this video, we haven't really touched on questions relating to summing arithmetic and geometric progressions using sigma notation. So the following question is a question from the 2004 Mathematics Advanced HSC paper. We can see that the problem is given to us in sigma notation. The question is asking us to evaluate or to find the sum of the terms between 2 and 4 of the given series, and the given series here is n squared. Our first step should be to write out the terms we are adding together, since there are only a few of them. From the sigma notation, we can read that we are adding terms 2, 3, and 4 of the sequence defined by the expression n squared. This turns out to be 2 squared plus 3 squared plus 4 squared. From here to solve, we can simply expand our values and solve algebraically. By doing this, we end up at an answer of 29.